backwards. And there's a bunch of rules to learn, okay? So this is the answer for the first one. So the first rule is that when you take the integral of x to the n, it becomes x to the n plus 1 divided by the new exponent. So you can see here the x squared becomes x cubed. The constant comes with it, but you divide by the new exponent. So we'll see that in the next problem here. But this is the answer for number 1. And then I'll try to give more explanation for the next couple. Is that okay?
Wait, sorry, I didn't put it in yet. I was writing it down. Okay.
All right. So for number 2 here, if you remember when we first started learning derivatives, there's a rewrite step. And the rewrite step here is to actually multiply in. So it's the integral of 5x cubed plus 20x dx. Is that okay? Okay. Now the antiderivative, let's start with the x cubed. You add 1 to the exponent and divide by the new exponent. And then this 5 also comes down. So you can see that it becomes 5 over 4 x to the 4th. This is really x to the 1, so it becomes x to the 1 plus 1. Divide by the new exponent and bring the 20 down. So that's 20 divided by 2 x squared. And then this 20 over 2 reduces to 10. So 5 over 4 x to the 4th plus 10x squared plus c. That's your final answer.
Okay.
Questions on that before we move on?
No.
Okay.
Straightforward.
All right, so for this one, it's the same idea. The rule here is that you add 1 to the exponent. 3/4 plus 1 divided by 3/4 plus 1, and then you bring that constant down. You add 1 to the exponent, and you divide by the new exponent. And this is where it's really helpful if you, as the student, are comfortable with fractions, but you have a calculator. So I would just recommend using the calculator. I wouldn't try to do any of this by hand. But it becomes 7 over 4 over 7 over 4 times 10 minus 6x to the 12 over 7 over 12 over 7 plus c. And then again, you could go to your calculator and you could do this 10 divided by 7 over 4, 6 divided by 12 over 7. It ends up being 40 over 7x to the 7 over 4 power minus 42 over 12 x to the 12 over 7 power plus c. And then you can reduce this this fraction here. This is 42 over 12. What's that? 21 over 6, and then divide by 3, 7 over 2. So it ends up being 40 over 7 x to the 7 over 4 minus 7 over 2 x to the 12 over 7 plus c. Any follow-up to that one?
Not that I can think of.
So the derivative of this would get you back to the original.
Okay.
That's why the derivative is so important. Like this will be one of your multiple choice answers, and the derivative of this will be what's here. So that's where your exam may not be as difficult. Famous last words,
Right.
but maybe will be.
Okay.
All right, so this one again, we're going to do a rewrite step. This is 3 times x to the minus 3 power dx. if you recall, 1 over x to the n becomes x to the negative n. That is the property that we are using here. Is that okay?
Yeah.
So again, the rule is you add 1 to the exponent and you divide by the new exponent. Bring the 3 down plus c. Again, just use your calculator if you're uncomfortable with negatives. Like, if no judgment, it's just you got to get comfortable with this.
Okay.
So now there's, like, I believe Pearson will accept this, but let's clean it up a little bit. So the 3 over negative 2 becomes negative 3 over 2. And x to the negative n becomes 1 over x to the n. So this is times 1 over x squared plus c. So the like preferred answer here is minus 3 over 2x squared plus c, like that.
All right.
Right. Any move on to the next one, or you have any questions?
Yeah, we can on.
Okay. Just a moment here. Grab a snip of that. So, all right. So this is like kind of a combination problem. I'm gonna have to learn like a new rule. So one of the first things you might notice is it's u instead of x. That's not a big deal. You treat it like it's an x, meaning you just do the same thing. So it's u to the 1 plus 1 power over 1 plus 1. Bring the 8 down. So that's the same as before. It ends up being 4u squared. The integral of e to the x dx is e to the x. Okay, and if you remember, I sent you that reference sheet a while back. I'll drop it in the chat again. The second page has some of these integrals that might be worth having, handy when you're working on these problems. Also, a million calculators online. You'll notice the big difference here. There's a number in front of the u. So when it's e to the kx dx, the antiderivative is 1 over k e to the x, and there's still a plus c there. So that applies to this first one. It becomes itself e to the 8u times 1 over 8. And again, when you get to this on the exam, you'll just take a derivative of this and see like which one is the derivative matchup. Let me know when you get that down. We'll move on to the next one.
Okay, got it.
All right, this one is more like the ones we were doing prior to now. Requires a couple of rewrite steps. So the first is that it's really x to the 1/2 plus 7 over 4x to the 1/3 power. And the property here is that if you have the square root, x to the m, or the mth root of x to the n, or you can switch this up. It becomes x to the n over m power, like that. I always remember that this is 2 and this is 1. That's x to the 1/2. So I remember it. So that's how we come up with this over here on the right. And then you can divide each of these by it. So it's x to the 1/2 over 4x to the 1/3 plus 7 over 4x to the 1/3. Yeah, no calculus yet. So when the bases are the same, like we have over here on the left, you subtract the exponents.
Okay.
So 1/2 minus 1/3 ends up being 1/6. So it's x to the 1/6, and there's really a 1 here, so it's 1 over 4. x to the 1/6 power. This one on the right is 7 over 4 times x to the minus 1/3 power. When you bring the exponent up, it becomes positive, or I'm sorry, it becomes negative when you move it up. All right, plus c. Oh, sorry, we haven't done the calculus yet. Never mind. All right, so same thing that we've been doing. You add 1 to the exponent, and you divide by the new exponent. Bring the constant down. And it's really just busy work from here, dealing with the exponents, the fractions and stuff. So it's 7 over 6, 7 over 6, 1/4, plus 7 over 4, x to the 2/3 over 2/3. And if you do use your calculator, just be careful there to put it in, correctly. It's parentheses 1/4 divided by parentheses 7/6. That will reduce it. Same thing with the one on the right. It's parentheses 7/4, 2/3 in parentheses, and do that math, enter to get your fraction. But having said all that, you're just multiplying by the reciprocal. So this is 6 over 28, x to the 7 over 6 power, plus 21 over 8, x to the 2/3 power, plus c. And then this one on the left does reduce to 3 over 14, x to the 7 over 6. Something like that. What's your initial reaction to seeing this? Do you feel like you can do it with some practice?
Yeah, I think it just takes practice because I feel like but it's easy. I think it'll be easier with a calculator
Yes, absolutely.
for sure, because there's just a lot of math that could get, if you do it by hand, you could get slightly different answer. If you make a mistake.
Right. Let's move on to the next grouping of problems, which require you to do the same thing, but they also ask you to solve for C, which is a little bit different.
Okay.
So what we're doing in this problem is we're integrating 0.03 e to the 0.01 x dx. And I showed you earlier, I said if it's e to the k times x dx, it's 1 over k e to the kx plus c. So this problem becomes e to the 0.01x, 1 over 0.01, but then you do bring that constant down, which is 0.03 plus c. All right, so this reduces to 3 in front. Okay, and then we use this initial condition. This fixed cost means that when x is 0, c is 10.
Okay.
So we're going to put those values in. 10 equals 3e to the 0.01 times 0 plus c. E to the 0 is 1. So 3 times 1 is 3. It becomes 10 equals 3 plus c. So c ends up equaling 7. Goes back in this position. So c of x equals 3e to the 0.01 x plus 7. That's what it is looking for there.
Okay.
Just step away. I'm going to step away for 30 seconds. Got a hungry cat. I'll be right back with you.
No worries.
All right. Moving on here. All right, now this one's a little grainy. I don't know why that always happens when I snip it over from my other screen. Okay, so you're integrating this time 0.01039 t plus 2.05 dt. So a new rule here, let me actually move this. New rule is the integral of a constant dx becomes c times x plus c. So that applies to this one here. So this becomes 2.05 t plus c. For this one on the left here, you're adding one to the exponent and dividing by the new exponent like that. Are you starting to get understand what we're trying to do here with that?
A little bit.
Okay, fair enough. Uh, we're covering like multiple days of a lesson in in an hour. So, all right. So this ends up when you divide by 2 here, ends up being a 0.005195 t squared plus 2.05 t plus c. And if you go back and look, it says in 2014, which is the base year. No, it is not the base year. The base year is 2000. So 2000 is t equals 0. So in 2014 and 14, there were 35,378 patents. So this initial condition is what we're going to use to find C. So after you do this integral, which I know you're just barely kind of getting comfortable with the idea of doing this, you then use this x and this y. So it's 35378 equals 0.005195 14 squared plus, and that doesn't seem right. Those numbers aren't going to be. All right, yeah, so it's actually 35.378.
Okay,
If you go back and read it, it says in thousands of applications.
okay.
Because that to say this won't work out very nicely at all. So we solve this for C. You square 14, you multiply by that number, add together and subtract. I'll do that in the other screen here. Does it say to round? It does not. Wow. It just, I mean, it works, but it ends up that C ends up being, I mean, it's just a lot of different C, and that's exact. No, that's why I can see that's where the mistake is. Sorry, that is not right. 5.65978. So the answer to that first box there, the P of T, is 0.005195 P squared plus 2.05 T plus 5.65978. I was looking to see if it was allowing you to round it, but it does not appear to want you to do that. Checking one more thing.
Okay.
0, 1, 0, 1, 0, 3, 9. Yeah. All right. I believe this is correct.
Okay.
For part B, it says predict in 2027. 2027 is t equals 27. You're just evaluating this function at 27.
Okay.
This one you do round to the nearest whole number, which is good for us because I'm not sure the previous one is exactly right. It doesn't feel right. Squared. All right, so I got I'm gonna multiply that by 1,000. All right, so it ends up being you have to multiply this by 1,000 because it says in thousands. 64,000 797. Any questions on that before we move on?
No, I don't think so.
Okay. All right, so yet again, some of the same. We got we're going to integrate this function, integral of 0.04 e to the minus 0.04 t dt. So the rule here is that you you bring down the e, whatever the e is, and you divide by the exponent. But you also bring this 0.04 down.
Okay.
Okay, and then it is plus c. All right, so these cancel. So you end up getting negative e to the minus 0.04 t plus c. That is the first box. That's the f of t.
Okay.
Is that okay?
Yeah.
All right, now for part B, they give you a little bit more information to use here, which it's kind of odd that they don't give you this for part A because you don't solve for the C, but they're telling you that uh, 0, comma 0 is your what's called your initial condition. So 0 equals minus e to the minus 0.04 times 0 plus c. E to the 0 power is 1. That negative in front remains. You can see that c equals 1. So c ends up being 1. So your f of t is actually, and this is why I don't quite understand this because it seems like that would be the answer to part A with the plus 1 instead of the plus c. But since, yeah, I think I would just go with what I suggested there. For part B though, it asks about in 8 minutes. That's when t equals 8 minutes. So you're finding f of 8 minus e to the minus 0.04 times 8 plus 1, and you're rounding to 3 decimal places as needed. And 0.274. That would be part B. Is that okay?
Mhm.
All right. Moving along here. So we got an object being dropped from a plane, and they tell you that the acceleration is minus 26. So the velocity function is the integral of the acceleration function. So the antiderivative of this thing we've been doing all day long here is minus 26t plus c. So if you can imagine the derivative of this is the minus 26. And then it tells you here that the velocity at time 0 is 0. This is what allows you to find the value of c. So we got c equals minus 26 times 0 plus c. And then c ends up equaling 0 as a result of that. So the v of t is just minus 26t. This is not the final answer. It's asking for s of t, which I guess is cut off here, which means you have to do another antiderivative. So s of t is the antiderivative of this right here, the v of t. This is a common test question, by the way, that they're giving you here.
Okay.
This might be one to look at again. So again, the rule here is you add 1 to the exponent, you divide by the new exponent, you bring the constant down. So this becomes minus 13t squared plus c. This time, though, they tell you that at time 0, it's dropped from 7,488 feet. And that's enough to be able to find this value of c. So 7,488 equals minus 13 t squared plus c. Sorry, that's 0 squared. That's your t. That's your, on the right's your s of t. So this ends up being 0. C equals 7,488. That goes in here. So s of t equals minus 13t squared plus 7,488, like that. That is your answer to box number 1.
All right.
Okay. The next box, it wants to know what's going to hit the ground. So the graph of this is that it starts up here and it's the ground. Boom. We're setting this equation equal to 0. So this is not calculus. This is like your previous courses. You're just solving for t. So t ends up being you move like this whole term over. You divide by 13. You take a square root, and it says simplify your answer. Huh? You can't imagine that works out, but it does. Wow, it actually works out perfectly. 24 seconds.
Oh,
All right, moving along to the next question here. So the rest of the integrals are what are called U substitution type problems. They require you to make an additional step to solve them. Your U substitution is generally like something in parentheses, maybe an exponent under a root, maybe in the denominator. I'm going to tell you what the U is in these problems, but like that would be the whole goal. The U in this problem is the 5x to the 5th minus 3. And then du, this idea of du is you're taking the derivative of the u. So that's 25x to the 4th is your du. So this is where a lot of students struggle because it's now going back and forth. It's integrals, it's derivatives, it's antiderivatives. You got to be really comfortable taking a derivative or going back and forth between them.
okay.
Okay, that is everything for that problem. Now we actually have to use the u in the next couple of problems. It's okay if none of this makes any sense.
Okay.
The answers, it'll be when you get to the test, it'll be different. I mean, it'll be multiple choice, I hope, and you'll be able to do some things here. So the u in this problem is 7x squared plus 4x. So notice that's the denominator without the exponent. Du, now we're going to take a derivative. So this is old stuff you previously learned. 14x plus 4 times dx. Now you solve for dx, which just means you're going to move this to the other side of the equation. So your dx is du divided by 14x plus 4. And then you substitute in two things. You substitute in your u and your dx. Okay, so you go back to your original problem. Only substitute for those. So the u, the 7x squared plus 4x, that was on the bottom. You keep the thing on the top. Dx is du over 14x plus 4, like that. So I just replaced, again, I kept the 7x plus 2. 7x squared plus 4x is the u. Dx is du over this. All right, now this simplifies in such a way that the x's go away. I can factor a 2 out of the bottom here. And then you can see that these cancel. 7x plus 2 cancels 7x plus 2. There are no more x's. It's du over u to the fourth. There's really a 2 down on the bottom. That's from this right here. And we're going to just sneak that outside. It's really 1/2. So this becomes 1/2 integral du over u to the fourth. And then this is now more like a problem we were doing earlier in the lesson today.
Okay.
So this is really, and this is a rewrite step now. It's 1/2 integral u to the minus 4 du. So your rule for this is you add 1 to the exponent, and then you divide by the new exponent. So it's minus 4 plus 1 over minus 4 plus 1. Bring down the 1/2 plus c. So this is u to the minus 3 over minus 3 over 1/2 plus c. So it becomes minus 1 over 6 times 1 over u cubed plus c. And you might wonder, when does this problem end? You have to back substitute. So u was originally 7x squared plus 4x. So that's going to go in for u like that. And then your final, maybe rewrite here is minus 1 over 6 times 7x squared plus 4x cubed plus c. That is your final answer.
Okay, you can leave it like that.
Yes. Again, this will be one of the answers. You could take the derivative of this and you will probably see it such a way that you can work through it. But the next few are like this. So yeah, it's a little bit, gonna be a little bit tough. Right, so on to the next one. All right, so the u in this problem is the exponent, the x squared plus 2x, the exponent of the e. The u, the derivative here is 2x plus 2 times dx. You always solve for dx. Dx is du divided by 2x plus 2. And then you substitute back in. So this u goes in here, so that's going to be u. And then the du, I'll use a different color here. This goes in for dx, ends up going in there for dx. So you only rewrite the stuff that you don't have substitutions for. So e to the u, and then du over 2x plus 2. You can kind of see now that x plus 1 and x plus 2, they have the chance to cancel. If you rewrite 2x plus 2 as 2 times x plus 1, you can see that these cancel. And you can see that this becomes 1/2 e to the u du. And so bring the 1/2 out. The antiderivative of e to the u is itself. It's the only one that's exactly itself. There's no like number in front of u, so you don't have to worry about dividing it. So the answer is just 1/2 e to the u plus c. And then you have to go back, well, what was my u? The u was x squared plus 2x. This becomes 1/2 e to the x squared plus 2x plus c.
Okay. Okay.
Next problem is really similar. It's another u substitution. In fact, the rest of them are. This time it's the bottom. The u is 5t to the 6th plus 3. The u is 30t to the 5th dt. This time you solve for dt. dt is du over 30t to the 5th. You're solving for this little thing here. And so that's what goes back in. This integral becomes, we don't know t to the 5th, but we know the bottom is u, and we know dt is du over 30t to the 5th. This time you can see that those t to the 5ths just cancel, and you have a 1 over 30 left over. It's 1 over 30, 1 over u du. So this is the first kind of exception to the ones that we've been doing. The integral of 1 over u du is the natural log of the absolute value of u. It's the one that's the exception to all of the ones we've been doing.
Okay.
So this is something to remember, that if it's u to the power of 1, 1 over u to the power of 1, it's this natural log absolute value of u. So what that means for this problem is 1 over 30 natural log absolute value of u plus c. U was 5t to the 6th plus 3. So that's going to back substitute in here. So it's 1 over 30 natural log absolute value 5t to the 6th plus 3 plus c, like that. And again, the idea here is the derivative of this is the original problem.
Okay.
That's why learning those derivatives was so potentially crucial for this.
Okay.
All right. Keep going here. Almost through. So this one, your u is natural log of 6x. Your du is 1 over 6x times 6 dx. That's the chain rule. Remember, the derivative of natural log is 1 over what's inside times the derivative of the inside function. It does reduce to just 1 over x times dx. dx is x times du. So that's important, because when we substitute in here, it's 7 over x times u. dx, or du, sorry, dx is x times du, and you can see that these x's cancel. And that's the whole point of this u substitution technique, is you're supposed to go back to something that you can actually do. So this 7 It actually comes out in front if you want, maybe makes it a little easier because then it's that 1 over u du. It's the one we just talked about. It becomes the natural log of the absolute value of u. And your u was the natural log of 6x. So it looks a little weird, but it is correct. Make sure you do use those absolute value bars. They are pretty picky about that in this especially. So previous one for sure, this one for sure. This one, it is parentheses inside, but this first one is the absolute value bars. Let me know we can go on to the last.
Oh yeah, we can move on. I took.
Okay. And just, yeah, just again, like these are absolute value bars. Make sure you include those.
Okay.
All right. More of the same, kind of like the Halloween that never ends. We have the u is the bottom here. Du is the derivative of 1 is 0. Derivative of e to the t is itself times the derivative of the inside function, which is 2. So when you solve for dt, it's du over 2e to the 2t. So we substitute that in here. It's 2e to the 2t over u. dt is du over 2e to the 2t. And then cancellations, which we love because it makes the problem so much easier. There's still a 1 on top, so it's integral 1 over u du. It becomes just the natural log absolute value of u plus c. And then you just back substitute the u substitution. And again, I would never expect you to fully understand this after
Yeah.
spending this little time, but good news is all of this is based on derivatives, which it seemed like you were getting pretty good at towards the end there, and will be definitely useful going forward.
Okay. That's good. I'll submit.
All right, gonna go ahead and stop the recording
Then
here.
all the